So now let's see the second problem and then we will wind up. The question states the wave function of a particle in a deep square well potential from x is equal to 0 from x is equal to L at t is equal to 0 is given by psi of x is equal to 1 by root 5 into the quantity phi 1 of x plus 2 phi 2 of x, this quantity. And in this we are going to study something really interesting about the bra and the cat symbol in this, because there are some operations which will be done using that. So you have to be very much concentrated towards this thing. Okay, so phi 1 and phi 2 are the energy eigenfunctions corresponding to the ground state and the excited states, right, respectively. So we have to find the wave function at t is equal to the time is equal to ml square by pi h bar. Okay, so first of all, let's see how the function may look. Of course, let's see. Phi 1 will look something like this, and phi 2 looks like this. Okay, so you are adding this. So in the first case it looks like this with something like this, and in this you will minus. So the final graph which you will expect to get is this. This is your wave function actually. This is your given wave function at t is equal to 0, right? Okay, and it will change with time. Of course, it will decrease, increase, then it will decrease, then increase over here, and so on and so forth, right? Okay, so let's see. Yeah, let me raise this. I hope you all must be knowing the question. Now we are solving the first part, and in that case we know that psi of x comma 0 is equal to summation I ci phi I of x, right? Okay, and psi x comma t, this ci at 0, and when you apply at time t it will be at 0 e to the power negative I by h bar into the quantity e I t pi I of x. Remember we had calculated this thing. Okay, this will be ci at t, and ci at t we had calculated this thing. Okay, if you remember that. Okay, so now you remember that psi of x comma 0 is equal to 1 upon root 5 phi 1 of x plus 2 by root 5 phi 2 of x. So psi at x comma t is equal to 1 by root 5 1 x into e to the power negative I by h bar into e1 of t plus 1 by root 5 phi 2 of x into e to the power negative I by h bar e2 t, right? And you all know that e1 is equal to, from the eigen values which we calculated, like we had calculated now, that en is equal to that we had assumed that k square is equal to 2 me by h bar, so we got en is equal to h bar by 2 m h bar square into k square as n pi by l whole square. We had got this now. So e1 when you substitute 1, and e2 when you substitute 2, and so on and so forth. You can watch that 1D part, that 1D box problem. In that we had calculated the eigenvalues. So this is e1 and this is e2 over here. And now when you evaluate this at given time intervals, at the given time you will end up getting psi of x comma t, and this is your work to solve this. You will get 2 phi 2 at x minus phi 1 of x, right? When you evaluate further completely, you will end up getting this. which means your wave function has changed, but the probability of energies and everything have remained still the same. That's the beauty of quantum mechanics. Okay, now the second part is something interesting which we will discuss, but first I have to get some space. So now let's see the second part, and it states that you need to find the expected value at t is equal to 0. Okay, so expected value at x is equal to this quantity I have told before, and you remember that ket of psi is equal to 1 by root 5 of the states. We are just accumulating all the states, this state, these two states, and then you're finding the bra symbol in with respect to psi over here and this. And notice when you apply the bra symbol over here, then in that case, if there's any complex, if it would be a complex function, then you would have taken the conjugate. Okay, but since it is a real, so we don't need to worry. This is bra psi phi 1 plus 2 bra phi 2. This, you get this thing. Okay, so now let's evaluate the things. Okay, let's see. So basically you get this operator over here, x. This is a position operator which you are applying. So it is 1 by root 5 whole square, of course, since you are using the properties over here, and it is equal to the bra phi 1 plus 2 bra phi 2 multiplied by x ket phi 1 plus 2x applied on phi 2, right? You get this thing. And just as in normal calculations you do, just multiply it, you get this, just like in the normal calculations you do. 2 times phi 1 this x and this is phi 2 plus 2 phi 2 x phi 1 plus 2x plus 2 plus 4 phi 2 over here, x over here, and phi 2 over here. Okay, and notice that over here we have done that this is the expectation value of x if the wave function was psi 1, and over here also. So notice that the wave function for phi 1, it is very much symmetric from 0 to L. So we expect the value to be at L by 2, and in the case of this, it looks like this, and when you square it, it will be like this. So again, the expected value, expectation value will be at L by 2. So for both the case, you will get L by 2 and this 4 into L by 2 plus, and notice that in this case there is no complex function over here, which means that they both are equal since they are real. Okay, that's 4 times this quantity. Okay, and how do we evaluate it? Let's see. Well, it's again the calculation part, that negative infinity to infinity of the quantity root 2 by L into sine of pi x by L pi x dot root 2 by L into sine 2 pi by L into x into dx. You evaluate it, and it's your work to evaluate over here, because if I evaluate it will take lots of time, and it's simple, just mathematics. It's your mathematical skills which you will save you over here. So you have to evaluate this, and you will end up getting minus 16 L by 9 pi square, right? You will get this. So you get 1 by 5 into 5 L by 2 minus 16 L by 9 pi square, and L by 2 minus these quantities. When you solve, you will get whatever result. This is the final answer which you will get. Okay? I hope you are understanding how we have calculated, and since it is a multiplier of 4 also, so you get L by 2, this 4, this 4. minus 64 by 45 L pi cube, pi square into L. And this is the probability at t is equal to 0, right? So with this we come to an end to our one shot, and I hope that you all really liked the video and understood something new over here, learned something new. So please do like and subscribe my channel, and please support this video as much as you can, and take care. Bye bye.